Hello, algebra students. Mr. Laurence here, and if I sound a little different, I'm just nursing a little cold. If I sneeze abruptly all of a sudden, I do apologize. There's no way to pause this video, so I'll try to keep it quiet. Well, it's halftime, watching my Buckeyes trounce Wisconsin. Not sure why we're the underdogs, but hey, we love it. Anyway, these two problems here, this red problem and this gray problem, they look very different to many of you. Many of you on that cluster assignment, the one that took some of you so long to turn in, you could do cluster 3 no problem, and you'd come to cluster 4 and go, write me these notes, but you don't know how to do it. Well, to me, they're almost exactly the same problem. And so what I thought I would do is I'm going to go through and set up both problems, kind of work them simultaneously, and show you how they are similar. Now, let's get down to this. And there will be a video quiz. It's right there, okay? By the way, after you watch this video, pay attention to the green problem. Watch it again, because if you're one of those kids who's not getting the video quiz question, it's the same type of question. Imitate those steps. Do as much as you can, and then I'll try to help you the next day in class. I'll have a couple problems for you to practice with. All right, so this red problem. Solve a quadratic, step 1, we want it to equal 0, and then we're going to factor. This problem is ready to factor, right? Because everything on the left-hand side is simplified, the right-hand side equals 0. This is good. We're ready to factor. It's quadratic. Okay, now this gray one isn't ready. We have to set it up, and many of you are very good at setting it up. I called some of you up to the board, and you'd go like this. Well, here, some of you would even do this. Let me show all the work. Sorry, close that rectangle, you'd go, well, the length times the width equals the area, or you might say base times height. And then you'd go 5x, quantity of 5x minus 1, times quantity of 2x plus 3. And that is going to have to equal 63, because the area is 63 inches squared, right? Okay, and then you should know to double distribute here. Okay, so we don't have to double distribute. We don't have any quantities. All right, so we're going to double distribute. I'm going to get 10x squared. Let's see, a minus 2x and a plus 15x. It's going to be a minus 13x. Right? No, silly me, I have a mistake. Sorry. Okay. A plus 10x. No, that was right. It was a plus 13x. That's what I'm doing. Plus 13x. And then minus 3. And that's going to equal 63. Now, this equation almost looks exactly like the Scarlet equation. So I'll just have to subtract a 63 so that it'll equal 0. So I'll subtract 63 from both sides. And when I do that, then I will get 10x squared plus 13x minus 66 equals 0. And now they're the same type of problem. This one's ready to factor, that one's ready to factor. So on this one, I'm going to list A, B, and C. And remember, A, B, C, easy as 3, negative 13, negative 10. And then I'm going to multiply A times C, right? And I'm going to ignore the negative. I'm going to use it when I do my subtraction, but I'm not actually going to multiply by the negative. So 3 times 10 is going to be 30. Now, I'm probably not going to do the square root on this one. This 30 number is pretty easy to work with. Listing the factors of it aren't that big of a deal. But I am going to need 2 factors of 30 that subtract to get negative 13. Well, look at this. What's 2 and 15? 2 times 15 is 30. If I subtract 2 minus 15, and then my level 2 kids really love to put that x in there, and I think that's just such a smart idea. Ooh, look at that nice little trim, like the black trim the Buckeyes have. Anyway, all right, so now I'm going to rewrite this equation. I'm going to rewrite it, and I'm going to scoot it down a little bit. I'm going to rewrite the equation, and I'm going to write 3x squared, and instead of writing 13x, I'm going to write a minus 15x and a positive 2x, and then I think that was a negative 10 it equaled, right? Or not a negative 10, C was negative 10. And there we go. This equation here and this form are the same equation, only I wrote the negative 13 as 2 separate terms. I don't get to pick any terms I want. I had to multiply A times C, get the factors of that, subtracted to get negative 13. So, and this gray one, in fact, I think I may slide that down a little bit. Oh, it's not moving together. There we go. Slide it down. Oh dear, I do not like when that happens, but it wasn't that big of a deal. Okay, here I'm going to do A, B, C, right? Okay, and in this problem, we got A, B, C, easy as 10, 13, negative 66. Some of you are wondering why do you have to put the negative? Well, when we do the quadratic formula, that negative will be very important. All right, A, B, and C won't change, but that negative will be extremely important. All right, so I'm going to do A times C and get 660. And, you know, this might be a good one to do the square root of. So I'm going to take the square root of 660. 660, take the square root of it. It is approximately 25 and 7/10. Okay, 25 and 7/10, right? That's only approximate. It's not a perfect square. Now, excuse me, I feel a sneeze coming on. I may sneeze soon, just to warn you. You might want to turn your volume down if I do. All right, we need to get 13. We need our two numbers. Right now we have this 25 and 7/10 and another 25 and 7/10. We need them to be 13 away. So I need to move 6 1/2. How do I know that? Because half of 13 is 6 1/2. So I could subtract 6 1/2, or I could add 6 1/2. Let's see what happens if I add 6 1/2. It looks like I'm going to get 6 1/2. It's going to be 32. It's going to be right around 32. Let's see if 32 goes into 660. I'm going to do 660 divided by 32. I mean, I came up with 32 and 2/10, so that's pretty close to 32. 20 and 625,000. No, it doesn't go in. Let's try 660, and let's round it up to 33, which of course is going to go in. Oh, look at that. It goes in 20 times. So 32 didn't work, but you see how I used kind of an intelligent guess and check to see where I should be. So I rounded it up to 33. When I did that, I got 20, and how far apart are 20 and 33? Well, they're 13 apart, and that's exactly what I wanted. So it doesn't exactly tell you the answer. You have to pay attention to what you're doing. So I'm going to have a 20x and a 33x, and which one's going to be negative? Well, I want a positive 13x, so my larger one is going to be positive, and then I'll do that. So now I'm ready to rewrite that equation. And let me see here, what was it? A was 10, so it's going to go 10x squared plus 33x minus 20x. You know what? I think I'm going to rewrite those. I think I'd rather put the 20x first because I like the GCF situation better. It's not wrong to do it the other way. You can still get the same answer. So I'm going to need a minus 20x, a plus 33x, and then a minus 66. And I'm going to get rid of some of my work because it's in my way. That will need to equal 0, right? Okay, well, now those two problems are back in the same place. I'm ready to do some grouping. So on this red one, I'm going to group like this. Right, put a plus in there. Then I'm going to GCF each quantity. So I'm going to pull a 3x out, get an x minus 5. And then I'm going to pull a 2 out and get an x minus 5. And get it equal to 0. And then finally, there's one more GCF. I'll pull that out front. 3x plus 2 equals 0. Now, I'm not done with this problem. I'm just done factoring. Okay, let's go over to the scarlet one. Excuse me, the gray one. And I'm going to group like this. Right? I'll put a plus sign in between. I'm going to factor out a 10x. And I will have, oh, I don't want that to be in that color. I want it to be somewhat consistent. Sorry about that. So you can follow the work of the gray problem because that's the one that's going to help you with the video quiz. So I'm going to pull a 10x out and be left with an x minus 2. And then I'm going to add 33 and be left with an x minus 2. That'll equal 0. It looks like I have an x minus 2 as a GCF. Pull it out, have a 10x plus a 33. And equals 0. No, this problem's not done either. It's just done factoring. So I'm going to solve for x. So I have to write two equations on this left-hand side. My x minus 5 equals 0. going to solve for x. 3x plus 2 equals 0. At this point, you're probably just watching, which drives me nuts. You shouldn't be watching. You should be pausing the video whether I say to or not, and trying to do steps on your own. Some of you do that in class, and it's awesome. And some of you are just so passive about your learning, I can't figure it out. So you really should be pausing the video now and trying to solve for x. If you didn't do it for that one while I was talking, please pause and solve for x on the second equation. All right, here I come, subtracting 2. I get 3x equals negative 2. And then divide by 3, and x is going to equal negative 2/3. So my solution set is negative 2/3 and 5. And what that means is, in the original equation, or in any form of the original equation, in this equation right here, if I let x be one of those two numbers, I think they were 5 and negative 2/3, right? Yep. If I let x be 5 or negative 2/3, I will get 0. Yeah. Now, on this gray one, I'm going to solve for x. And again, I'd like you to try it on your own. Okay. Set up your two equations. Try it on your own. When you're ready, unpause and see what I'm doing. So I've got x minus 2 equals 0. And 10x plus 33 equals 0. And so I'm going to add 2 to both sides. X is going to equal 2. Get 10x equal to negative 33. I just subtracted 33. I'll divide by 10. I'll divide by 10. And I'll get x is going to equal negative 3 3/10. I know you might find it strange that I went to a decimal there, but that's a relatively easy division, and it looks a little bit easier than the mixed number. Okay, so that's why I did it. Now, it looks like I have a solution set of two numbers, but the question is asking for the dimensions of the rectangle. Now, I don't know the dimensions. I know they're 5x minus 1 and 2x plus 3. Well, I know that x can be one of two numbers. It might be 2. It might be negative 3 3/10. Let me go back up here. Let's see what happens if x is 2. Okay. If x is 2, and I don't want you to do this, I don't want you to erase work, I'm going to erase my work so that I can do it right next to the problem. But if x is 2, the top side, or the base, or whatever you're calling it, becomes 5 times 2 minus 1, which equals 9 inches. The bottom side becomes, or excuse me, the vertical side becomes 2 times 2 plus 3, 4 plus 3 that's unnecessary, sorry, that equals 7 inches. And so the length is 9 inches and the width is 7 inches. If I multiply 7 inches by 9 inches, I get 63 inches squared. That's awesome. If I use negative 3 3/10, I get 5 times negative 3 3/10 minus 1. And I'll also get 2 times negative 3 3/10 plus 3. All right, so 5 times this is a negative number. Minus 1 is a negative number. X cannot be the negative 3 3/10 because it'll cause the sides of the rectangle to become negative. Now, that doesn't mean that if you see a negative when you solve for x, that you should automatically throw it away. You shouldn't do that, okay? That's not okay. But once you've tested it and you find that one of the sides turns negative, and you may have to test it on both sides because they may not both become negative. All right, once you've done that, you can throw it away. So I know that my solution set is 2. And furthermore, I know that the length of the rectangle is going to be 9 inches, and the width will be 7 inches. And there you go. All right, so here's the video quiz. Just like the gray problem. I guess I wrote it in scarlet. I apologize. Go back and just do it. It's so simple. All right, that'll be it for tonight's video. Mr. Laurence signing off. Have a good night, everybody.